everybody, welcome to another edition of the Lab 207 webcast. My name is Mr. Kite and I'll be hanging out with you today as we continue on in our series about ecology. Topic for today is going to be biogeography and the impact of pathogens. So like always, let me get you your objectives and we'll get going. By the end of this video, two things I need you to know or be able to do. First one is to explain factors that can impact the biodiversity of an area. The second is to understand the role of pathogens in the determination of biodiversity. Today's going to be all about factors that can either increase or decrease the biodiversity of an area. So to get started, I want to talk a little bit about the idea of biogeography, which basically talks about the interaction between the area, like the habitat of a region, and the biodiversity of a region. It basically looks at how location affects the biodiversity of a region. So we're going to talk about a couple different location-related ideas with regard to biodiversity. We're going to talk about things that make animals sick, and that'll be the day. So talking about things that can affect the amount of diversity in an area. One of those things is the latitudinal gradient. And here's what I mean by that. Going way back to the early 1800s, researchers started to realize that in the tropics around the equator, there was much greater biodiversity than there were at either of the poles. And they generally found that if you start at the equator and move north or south, the biodiversity generally goes down along a pretty consistent decline. The next couple slides are going to give reasons that have been proposed for why that is, but to start out with, just kind of get in your head, biggest diversity at the tropics, and then that biodiversity decreases as you head north or south. One of the reasons that scientists think that biodiversity might be greater at the tropics is the issue of time. Two things related to time. The first thing is the growing season. So at the tropics, you don't really have seasons. You've just got summer pretty much year-round because it gets a constant amount of sunlight, which means that there aren't really seasons. Rainfall is going to be pretty consistent. And then as you move north or south of the equator, because of the effect of seasons, you start to get summer, winter, spring, fall, at the middle latitudes, and then all the way at the poles, you've got a couple months a year where the sun doesn't even come up. So because plants at the tropics don't really have to deal with those seasons, they can continually grow and they can go through generations much more quickly. And we know that faster reproduction time is more fertile ground for mutation, which is more fertile ground for natural selection, which allows for more speciation events. Another thing that I guess relates to time is the fact that the tropics are generally less disturbed by natural events such as glaciation or huge storms or things like that. So because you don't have like glaciers scouring the tropics, the tropic biomes are generally older than the ones at either of the poles or away from the equator, so they have also had more time to for mutations to happen, which has allowed for more speciation to occur. So time, one of the reasons why the tropics may be more diverse. Second thing is resources. The tropics have got more of everything. They get more sun, they get more rain. We know that both of those things are critical to the growth of plants, and we know that plants are critical to the number of organisms that can live in an area. So simply because they've got more resources, the tropics have the ability to be more diverse than other places in the world. Now, another thing, this doesn't relate to the tropics versus the poles, but it's something else that scientists have kind of realized. And they've realized that the bigger an area is, the more biodiversity it has. And the reason for this is that in a bigger area, you've got more diverse habitats, so you've got the opportunity for more diverse habitats. So if you've got more microclimates or microhabitats, then you will have more niches for animals to fill. And as animals adapt to niches, they will speciate away from their original species. So area provides the opportunity for greater diversity of climates, which provides for the opportunity for greater diversity of animals. And all of this kind of ties together into the idea of island biogeography. And basically what scientists realized is they were researching, looking at islands, same latitude, so physical characteristics should be about the same. If an island is smaller, it generally has a lower biodiversity. If it is bigger, it has a higher biodiversity, which goes back to the slide I just talked about with, availability of habitat and resources and niches and things like that. But they also realized that if an island is closer to a mainland, it has greater biodiversity. If it is further away, it has less biodiversity. And the thought behind that is that if an island is closer, then it is more likely that animals will be able to immigrate from the mainland than an island that is further away from the mainland. Now, this idea of island biogeography can be applied to not just like islands out in the ocean, but habitats that are separated off from the rest of the habitable habitats. So you can think of like the top of a mountain surrounded by a valley all the way around, or you could think about a forest habitat that's been cut off on all sides by human development. Those would also be examples of islands. So factors to put together: bigger island, more biodiversity; smaller island, less biodiversity; closer to the mainland or closer to another habitat, more biodiversity; further away, less biodiversity. And kind of wrapping all of this up, I've been talking about things that increase biodiversity. Let's talk about something that decreases biodiversity, and that would be pathogens. Now, we know pathogens have wreaked havoc upon the human population for all of history. Pathogens also affect all other living organisms. So these little beasties have the ability to kill, sometimes indiscriminately. So obviously, if you've got an organism that is taking out a population, that is going to decrease the biodiversity. But something that's not often thought of is the cascade effect of a pathogen potentially taking out one species, which I'm going to wrap up with on the next slide, and then that'll be it for the day. So a couple examples of pathogens dramatically impacting an ecosystem. First one would be corals. There is a disease called white band syndrome that occurs in corals in the Caribbean Sea, and basically it causes the coral tissue to slough off of the coral reef. As that tissue dies, coral skeletons are left behind. Coral skeletons then crumble, which makes the coral reef go from a beautiful like 3D structure that's very complex, it's got a lot of nooks and crannies, to a rubble pile. So that just shape change takes away a lot of the habitat that different organisms would inhabit. Also, it changes the structure of the community. When the coral tissue sloughs off, algae quickly comes in, and fish that graze on algae start to dominate the community rather than fish that would have lived in the area previously. So a healthy coral reef could have healthy coral reef could have thousands of species on it, where one that has been crippled by white band syndrome may only have a few species on it. Another example of it is there is a pathogen, a fungus, that affects oak trees in the California and Oregon region. That pathogen causes sudden oak death syndrome, or SOD, and they noticed it around the San Francisco Bay Area that several trees were dying off very quickly, and it ended up extending all the way from San Francisco up to southern Oregon, where all of these oaks were dying off. As the oaks died off, the habitat for several different types of birds that lived in the oaks was destroyed. So not only did the oak trees die, but the birds that depended upon those oak trees also started to move out of the area. So those would be two examples of pathogens decreasing the biodiversity of an area. And with that, I'm done talking for the day. I hope this was a decent little intro to you of how, I guess, geography can affect biodiversity. Thanks for joining us on the Lab 207 webcast. My name is Mr. Kite, and we'll see you again.